Hello, in this video we're going to take a look at a couple more examples of substitution. So our first example, we have the integral of e raised to the square root of x plus 1 all over the square root of x dx. So if we were taking a derivative of this, we would need to use the chain rule because of this exponent, and so that's what we are going to let our u substitute in for. So our u is going to be the square root of x plus 1. And the derivative of that is, well, the derivative of the square root of x, that's the same thing as x raised to the 1/2. So that's 1/2 times x to the negative 1/2. And then the derivative of the plus 1 is 0. Multiply both sides by our differential dx. And this, don't see anything exactly like that, so I am going to go ahead and multiply both sides by the reciprocal here. So that's going to be 2 times x to the positive 1/2 to get that dx by itself. And then we can substitute in, and we'll get e to the u in the numerator. We still have the square root of x in the denominator, and then our dx is going to be replaced with 2 times x to the 1/2 du. Now x to the 1/2, remember, is just like the square root of x, so that is a common factor we can divide out. So I'm going to go ahead and divide that out, and we'll be left with 2 times e to the u, integrating that with respect to with respect to u. So that integral is going to be 2 times e to the u. The integral of e to the u is e to the u. Don't forget plus c. And then our last step here is to go back to our original variable. Our substitution here was u was equal to the square root of x plus 1. So that's going to go back in our exponent, and we are done. All right, this next one is what I call a double substitution problem. And we'll see why in just a minute. If we go through the same basic approach, we've got an x minus 8 in that square root. Here our integral is 6x over the square root of x minus 8. And so that x minus 8 in the denominator there, we're going to let u be x minus 8. And du is going to be equal to, the derivative of x minus 8 is just 1, so our du equals dx. And when we substitute back in, we're going to be left with 6x in the numerator. We haven't done anything with that just yet. In the denominator, we're going to get the square root of u. And then our dx is equal to du. Now, this is a little bit different than the other examples we've looked at because the x that's left here isn't canceling out. And so what we need to do is we need to substitute in again. Now, we can't change our variable again, but we can rearrange our substitution and find an expression for x. So what we're going to do is we're going to solve this for x by adding 8 to both sides. So we get u plus 8 is equal to x. Now we can plug in for that x. And so we get 6 times u plus 8. That's still all over the square root of u. And now we've got everything in terms of our integration variable u. Now we just need to figure out how to integrate this. I'm going to go ahead and distribute that 6. So we'll get 6u plus 8 over the square root of u. Now, still not seeing a big clear way to integrate this, but we just have one term in the denominator. So we can do the opposite of adding fractions and actually break this up and write this as 6u over the square root of u plus 8 over the square root of u. That should be 48. Sorry about that. When we distribute that 6, we need to distribute it to everything. And then so what we've done here is just the opposite of adding fractions that have a common denominator. And we can simplify that first one. U over the square root of u. If we have a power divided by a power, we're going to subtract those exponents. So this is 6u is the same thing as u to the first. And then that square root of u in the denominator is the same thing as to the 1/2. So that's going to leave us with 6 times u to the 1/2. And then in the second piece, that is, we don't have any u's in the numerator, so that's going to effectively be 0 minus 1/2, or u to the negative 1/2. Now we have it in a form where we can take our power rule. So we can take our integral here, and we're going to get 6 times the integral of u to the 1/2. We're going to add 1 to that exponent, and we're going to get u to the 3/2 divided by 3/2. And then we're going to have 48 times u to the negative 1/2 plus 1 is going to be u to the positive 1/2 divided by 1/2 plus c. Dividing by a fraction is the same thing as multiplying by its reciprocal. So this is going to be 6 times 2/3 u to the 3/2. And 48 times the reciprocal of 1/2 is 2 u to the 1/2. So if we simplify that coefficient, that's going to be 12 over 3, or 4. And our u, remember, if we go back to our substitution, our u is x minus 8 to the 3/2. 48 times 2 is 96 times our u, which is x minus 8 to the 1/2, plus that constant of integration c. And then if you wanted to go ahead and factor out your GCF, you would have a GCF there of 4 times x minus 8 to the 1/2. All right, I'll see you guys next time.